Hello everyone, welcome to Almighty Tricks. So in this video we'll be understanding on bipartite graph and we'll see how we can write the bipartite graph logic. Okay, so to begin with, first of all we need to understand the what is graph coloring and what is chromatic number. So if you don't know about all these concepts, graph coloring and chromatic numbers, so I'll suggest you to see my previous video. You can find the link in description or you can check the I button. Okay, so let's get started with the bipartite graph definition. So the definition is saying definition is saying if we can divide all the nodes in two sets such that no two nodes in same set are adjacent to each other. Okay, so what it means, so let's take one example here. So this is a graph, right? This is a graph, and so it is saying this one is a node, two, three, all these things are nodes, right? So let's put this one node in set A. So we need to divide into two sets. Okay, we need to divide into two sets. So I have created two set A and B. Let's put one node in the A, then let's check 2. So 2 is adjacent to 1. Okay, so we cannot put 2 in A. Okay, so it is saying two nodes in the same set are adjacent to each other. We cannot put. Okay, so 2 will come to B. Okay, let's check 3. 3 is adjacent to 2. So 2 is already present in B, so we need to put in A. 4 is adjacent to 3. So 3 is already present in A, so we need to put it in B. 5 is adjacent to 4, so 5 should be in A. 6 is adjacent to 5, so 6 should be in B. 7 is adjacent to 5, 5 already present in A, so it should be in B. Okay, now let's do one thing. We'll connect all these adjacent here. Okay, let's 1 to 2, 1 to 2, then 2 to 3. Okay, then 3 to 4, 4 to 5, then 5 to 6, then 5 to 7, then 1 to 6. Okay, so if you observe one thing, in A set the nodes are 1, 3 and 5 is present. In B set 2, 4, 6, 7 is present. So these nodes are not connected to each other. There are no adjacent between them. And 2, 4, 6, 7 also there are no adjacent between them. So it is a bipartite graph. So it is a bipartite graph. Okay, you understood, I think. And one more thing. So in my previous video, I already told if the chromatic number is 2, then that graph is called a bipartite graph. So let's color this graph. Let's color it red, green, red, green, red, and green. I can color it to green. So the chromatic number of this graph is 2. Okay. So it is a bipartite graph. Got it? Let's check another example. Okay, so 1, 2, 3, these are the nodes. Let's put 1 in A set. Okay, 2 is adjacent to 1, so we cannot put it in A, so put it in B. 3 is adjacent to 2, so 3 should be in A. Then 4 is adjacent to 2, so it should present in A. And 6 is adjacent to 4, so it should be in B. Now come to 5. Okay, so 5 is adjacent to 2, so 2 is already present in B, so we cannot put 5 here. 5 we cannot put. Let's check for 4. 4 is also adjacent to 5 is adjacent to 4, so 4 is also present in A, so 5 also we cannot put here. So it is not a bipartite graph. Not bipartite graph. Okay, now color this one to check the chromatic number. It is red, green, red, green, then red. Now this one. So the adjacent is red and adjacent is green. So we cannot put red or green. Here we need to choose another color, let's say yellow. So now chromatic number here is 3. So it is not a bipartite graph. Understood? Okay. Now let's understand the logic. How we can write the logic. Okay. So the logic is basically see um, to, let's say this is the graph. Graph 1, this is the node 1, this is node 2. Okay, so I colored this node as a red. Okay, I colored this node as a red. So let's say I don't know the color of this one, I don't know color of this, all this thing I don't know, let's say. Okay, so to color this node 2, I need to check what color present in the parent. So 1 is the parent of 2, right? 1 is the parent of 2. So first of all, I need to check what color present in 1. So it is saying red. Okay. So I cannot put red here because if I put red here, then it will not be a bipartite. So I need to choose something else. Let's green I choose. Okay. Now check this one. 3. So 3 will check 2. Okay. 3 will check its parent 2. It is green. So I can put red here. Okay, I cannot put green. Similarly, I need to check parent then put parent then put. Okay, so here see this is the parent and this is the child. Okay, let's say parent color is red, so I cannot put red here. I need to put some different color. Let's say green. Okay, let's say this is green. Parent is green. Then this should red. Okay, some different color it should be. Okay, we are going to color uh, this node with 0 and 1. Okay, yes, 0 is one color and 1 is another color. Okay, so what we'll do, we'll take so we can solve this question, solve this bipartite graph in two ways, using BFS or using DFS. So in this video I'll be using DFS and I'll write the pseudocode for this. Okay, so let's check the DFS code. So I'm assuming that you know how to build the graph. Okay, okay. So let's say this variable is graph, which is having some 2D array. Okay, and we need to create one color array. Okay, and it should be initially with -1, initialized with -1. Okay, and I need to see this is the graph, right? Let's say this is one graph, 0 1 2 3. So this is, let's say, one graph. Okay, so first I am coming to this node, then I am coming to this node. Okay, so let's say I am starting with the node 0. Okay, so node 0 I am initializing with 0. So this is the color, right? So I already told you this is the color. Okay, I need to call the DFS. Okay, this is graph. I need to pass, then I need to pass the parent is 0. So this is the node 0 node, and I need to pass the color. Why I'm passing parent? Because based on the parent I need to color the child. That's why I'm passing the parent. Okay, now check the DFS code, DFS method. Let's write. So it should be a boolean type. Return type will be bool. Okay, and DFS. Okay, so here I have the graph. Okay, this is parent node, and this is color array. Okay, now from the parent, and also I am assuming that you know the DFS code for the graph. Okay, so here what I'll do, I'll take the for loop, and from the parent I can get the child, right? So child will be graph of parent. So I'm writing the pseudocode, so maybe the syntax will be different. Okay, so here I'm getting the child. Now what I need to do, I need to check this child is already visited or not. So how can I check that one? So if you see, we are initializing with -1. Okay, so -1 means it is not yet visited, not yet colored. Okay, so if it is not colored, then we need to color that one. So if graph of, sorry, so if color of child is equals to -1, it means what? It is not yet colored. So we need to color this one. So how we can color this? Color of child. We can color it by checking the parent, right? We can color the child by checking the parent. So what we'll do? We'll check the color of parent is equals to 0. If it is equals to 0, then it should be opposite, like this is 1. Otherwise it will be 0. Got it? Now we'll run DFS again. Okay, we'll run DFS again. So we'll pass the graph here, then we'll pass the child, then we'll pass the color array. Okay, so if it is not true, if it is returning, it is return boolean, right? If it is not true, then we'll directly return false. So it is not a bipartite. Got it? Else this else. Okay, this else is for this one. Okay, so else we need to check if the parent color and child color are same, means parent is green and child is green, let's say. It means what? It is not a bipartite because adjacent color cannot be same. Okay, so that part we need to check. If it is already visited, means if it is already colored. Okay, if it is already colored, then we need to check color of child is equals to color of parent. If it is true, then we know that it is not a bipartite. So we need to return false. Fine. Finally, we return true. Got it? Hope you understood this pseudocode. Okay. Now check the code. So this question is saying we need to check whether a graph is bipartite or not. So it is given a number of nodes. It is given number of nodes, and it is given this array, uh, adjacent arrays. Okay. So from this array we need to prepare the graph. So here I am preparing the graph. Okay, and I am declaring the color array. Okay, and it is size of n+1. Why n+1? Because this label is starting from 1 to n. If it is 0 to n, then I can put only n, but it is starting from 1 to n, so I have put n+1. Okay, and now initially I am filling with -1. Okay, I'll come to this logic later. First check the DFS method code. Okay, so this is the DFS method call. So I am passing graph, parent, and color. Okay, so if you see here, so in this for loop, I am getting child from the parent. Okay, and I am checking if child color is not yet filled, so I need to fill that one. So color of child is deciding from the color of parent. So if it is 1, then I need to put 0. If it is not 1, then I need to put 1. Okay, then I am calling DFS. Okay, if it is returning false, then I can directly return false. It is not a bipartite graph. Okay, and if it is already filled, some color is filled for this child node. Okay, I need to check this parent color and child color. If both are same, then it means adjacent nodes are same color, so it is not a bipartite, so I need to return false. Otherwise I need to return true. Okay, now let's see what this means. Okay, so this means, let's say a graph is given like this. A graph is given like this: 1 2 3. Okay, so this is a disconnected graph, right? So to handle this disconnected graph, we need to run like this. Okay, so it will start from 1 till I less than equals to n, because it is starting from the 1. Okay, and I am checking if it is not yet colored, so I am coloring this one, and this is a parent, right? This is a parent, so this node is a parent, right? So I am passing this parent, and finally I am returning true. If it is returning false, means I can directly return false. I no need to check anything, and finally I am returning true. Okay, and this is the DFS code. So this is the DFS code, and I have already written the BFS code, so you can check this one. This code is very simple. You can check this one, and you can try to understand all these things. If you are not able to understand, let me know in the comment. I'll try to explain those things. Okay, thank you for watching this video.